Hello everyone, my name is Danxu Zhang. I'm a third-year PhD student from electrical engineering. This semester, I took a course called financial modeling. It's a very useful course that I learned many background knowledge about financial modeling. Also, my skills, including MATLAB, Python, R, and SAS, are improved. The course is taught by Dr. Du, who is a very kind professor. And I have three students that work together for our project. Chen Ying and Xiao Wenxiao. We have a very good correlation. And I highly recommend this course for you if you are interested in financial modeling. Also, you are seeking to improve your skills of those softwares and programming.
Hello everyone, my name is Ying Chen. I'm the first year master's student in applied financial math. For this semester, I'm taking the financial programming and modeling with Dr. Du. I really learned a lot from it. Since it's a financial modeling course, I learned a lot about quantitative trading, such as efficient frontier and data development analysis. Here, I would like to say thank you to my teammates Wenxiao and Danshi, who are really collaborative and supportive all the time. Since all of our work are based on the team collaboration, it's really nice to be teammates with them. Our final project for this course is portfolio optimization, which is a very interesting topic, and I hope you guys will enjoy it. Thank you.
Hello, my name is Wen Xiao and I'm a second-year master student in statistics department. I choose this class because I'm interested in financial world and it turns out to be a great decision. I've learned a lot knowledge in financial programming in this semester, and also I acquire a very useful skill, Python programming. I believe that will be very helpful in the future. Here I want to thank my teammates. They've always been supportive and collaborative in this semester. I cannot finish this without their help. And in the end, I want to thank Dr. Do for his great lectures. I hope you guys have a great summer.
For our project, we are studying the portfolio optimization. So we are from Group 6, and the team members are Ying Chen, Wen Xiaoxiao, and myself, Danxu Zhang. First, I will introduce our project. So the whole project is done in the quantopin as required. And our problem, as I said, is to find the optimized portfolio. In this project, we explore two methods. One is data development analysis, linear programming, and the other one is mean variance efficiency. On this page, I will introduce some background for the EDA. Given a decision-making unit, which is short for DMU, so the idea of DEA is to obtain a set of weights that is efficient DMU leading to a best practice frontier. There are mainly two types for this problem. One is with single input and single output, and the other one is with multiple inputs and multiple outputs. The efficiency of the unit is defined as the equation here shows. So this part is for the outputs and this part is for the inputs. Here D is the number of units and N is the number of inputs, M is the number of outputs. U here is the weight for the output, and V here is the weight for the input. So the basic idea here is we want to maximize our output and minimize the input. And this one can be done based on different methods, and we can choose different constraints for this problem. For example, setting the outputs here as 1 and we minimize this part, or we can set the denominator as 1 and we maximize the numerator. So for our problem here, we select the 3 stocks for 20 days as our data, and we select the 20 days open price as our inputs, and the close prices are outputs for our problem. So for each stock, it is as one decision-making unit. The whole problem here is based on the assignment 7.1. Here we set the numerator to be 1 and we want to minimize the denominator by using linear programming package. Here, one constraint is all the weights are assumed to be non-negative. This is the first problem we are done in our project. So to make the problem more reasonable, we also explore the second one. So this is based on mean variance efficiency. Here still we give different stocks by using quantoping, and our idea is to obtain the efficient weights with high mean, which is high expect return, and we want to have the low variance. So based on our lecture, a nonlinear optimization problem is formulated. The reason here because we consider the variance, so the problem becomes a nonlinear problem. And this can be solved by using nonlinear programming package. The tests for our project is based on assignment 6.2. Here we want to maximizing the trade-off between the risk, which is shown on the equation on the formulation here. In the first blue box is expected return, and the second box is the risk. Here we want to maximize this objective function, which is we want to have a high expected return and a low risk for our problem. And here our constraint is sets all the weights, the sum of all the weights to be 1.
Hi, this is Xin. Now we are going to talk about our code used in this project and the result of it. First, we would like to talk about the portfolio maximization based on DEA. First, you can see in here, since using DEA is not reasonable for this problem, we decided to find the mean variance efficiency portfolio. First, we load the required package to set up the environment. Then we define a function to call the data of 10 stocks. We also define a schedule function to adjust the result daily. And here is our main function to compute the weights of stocks in the portfolio to find the mean variance efficient portfolio based on the formula. Here, lambda is the risk aversion coefficient. The importance of portfolio variance can be adjusted by the value of lambda. For example, when lambda equals to 0, we don't care about the variance anymore. The optimized result will have a high variance. And we also need to print the following results. Weights of the stocks in portfolio, expected return of the optimized portfolio, and the standard deviation of expected return. And here is the result of weights. When we can see that when lambda is large, we pay more attention to the variance of the portfolio in order to reduce risks. When lambda is smaller, we don't care about the risks that much. Therefore, the amount of the stock which is bought or sold is relatively high. And here also shows not only the weights, but also the expected return and the standard deviation of it. And we can see that for higher lambda, both of the expected return and the standard deviation for our optimized portfolio are smaller than that for the lower value of lambda. Hence, For portfolio with smaller lambda, a higher expected return and higher risk can be obtained.
This is our code for mean variance efficient portfolio. First, we just important some modules, which we are going to use later in our code. Then in the initialize step, we first set up this empty vector, and later we are going to use this vector to store all weights of this portfolio. And then we choose 10 different stocks to form our portfolio. And the schedule function is used because we want to update this portfolio every day, just 1 minute after the market opens. Then in the handle data step, we are going to use the last 60 stock price of these 10 stocks. And then we calculate their covariance matrix and their mean vector. And here we set up the lambda, which is the risk aversion coefficient here equals to 1. Then based on the mean and covariance, we set up the matrix for our optimization. After this optimization, we have the weights of this portfolio. And using the weights, we can calculate the expected return and the risk. And here the risk is just the standard deviation of this portfolio. And in the end is our output function. And we use print weights function to print the weights of this portfolio, as well as the expected return and standard deviation. We will choose May the 1st to May the 8th in 1915 and to draw this portfolio. Okay, here is our results. And the first row is just the weights of this portfolio, and the second row is the expected return, and the third row is the standard deviation. And we can see here we set up number equals to 1, which means we are willing to take great risk in order to achieve a higher expected return. But if we change this to 10, which means we are not going to take much risk here. Let's see how this works. Okay, in this case, we will have a much smaller expected return and a much smaller standard deviation.
This is the end of the video for our project of portfolio optimization. I hope you guys will enjoy it. Thank you so much.